This section describes the correlations between the three target variables, y1, y2, and y3. It shows that y1 and y2 are strongly correlated, y2 and y3 are moderately correlated, and y1 and y3 have a weak correlation. This information is crucial for deciding the optimal order of the variables in the regressor chain model, which is explained in more detail in the next row. Given the correlations from the previous row, this is the suggested order for the regressor chain. The model will first predict y1. Then, it uses the predicted value of y1 as an additional feature when predicting y2. Finally, it uses the predicted values of both y1 and y2 as additional features when predicting y3. This approach leverages the correlations between variables, where the strongest correlations are addressed before the weakest ones. This approach is likely to improve the prediction accuracy compared to using a different ordering or an independent multi-output regressor. This line describes the correlation between the three target variables, y1, y2, and y3. The greater than symbol indicates the direction and strength of the correlation. y1 is most strongly correlated with y2, which is moderately correlated with y3, and y1 has a weak correlation with y3. This is crucial for understanding how regressor chains should be structured for optimal performance. Think of it like a chain reaction. A strong link between y1 and y2, a weaker one between y2 and y3, a very weak one between y1 and y3. We need to place these accordingly in our regressor chain, reflecting this information. This describes the strength of the relationship between y1 and y2. A strong correlation means that changes in y1 are strongly associated with changes in y2 and vice versa. In a regressor chain, leveraging this strong relationship can lead to better prediction accuracy for y2, as y2's regressor can use y1's predictions as an input feature. This indicates the correlation between y2 and y3. It's weaker than the correlation between y1 and y2. It suggests that while changes in y2 are somewhat related to changes in y3, the relationship isn't as strong or predictable. This represents the relationship between y1 and y3. This correlation is the weakest of all three pairwise relationships. Because it's weak, using y1's prediction to predict y3 might not provide significant benefit within the regressor chain. This section introduces the core concept. We're tackling a multi-output regression problem, meaning we're predicting multiple variables at once. We're comparing two scikit-learn approaches, multi-output regressor which treats each output independently, and regressor chain a more sophisticated method that chains together regressors, using the predictions of one as input for the next. It's like an assembly line for predictions. The core question is, when is regressor chain better than multi-output regressor for multi-output regression problems? It all hinges on the relationships between the target variables. This sets the stage. We start with a specific scenario. Using multi-output regressor a scikit-learn function, but we're considering switching to regressor chain We have three correlated target variables, y1 y2 y3 with varying degrees of correlation. This sets the context for evaluating the statements that follow. This is crucial for understanding the strengths and weaknesses of the different regression strategies. Statement A claims that regressor chain always outperforms multi-output regressor We'll analyze if this is true or false. Statement B suggests that the order matters in regressor chain Let's explore whether the sequence of predictions influences the outcome. Statement C hypothesizes that regressor chain is especially useful when target variables are strongly related. Is this true? We'll examine if this aligns with how regressor chain functions. Statement D states that regressor chain ignores correlations. Does this statement correctly reflect the behavior of regressor chain This section clarifies the relationships between the three target variables, y1 y2 y3 The strengths of these relationships are indicated as strong, moderate, and weak. This specifies the strong correlation between y1 and y2. This specifies the moderate correlation between y2 and y3. This specifies the weak correlation between y1 and y3. Okay, so we're tackling a multi-output regression problem. We need to predict three different variables, y1, y2, and y3. And the key here is that these variables aren't independent, they're related in some way. This sets the stage for understanding how a model like RegressorChain might be helpful. This line describes the correlation between our target variables. y1 has a strong relationship with y2, meaning changes in y1 tend to be reflected similarly in y2. However, the relationship between y1 and y3 is much weaker. This information is crucial when we consider the order of variables in the regressor chain. Here we see that y2 and y3 have a moderate correlation. It's not as strong as the y1-y2 relationship, but it's still significant enough to potentially impact our model's performance. This further emphasizes the importance of carefully considering the variable order in the chain. This simply indicates the third target variable in our prediction task. It completes the picture of the relationships between our three target variables. This depicts the structure of a regressor chain. Imagine a series of connected regressors, each building upon the previous one. The first regressor uses the initial input features to predict the first target variable. The second regressor then takes those input features plus the first regressor's prediction as inputs to predict the second target variable, and so on. It's like a chain reaction, where each link depends on the previous one. These are the initial features that are used to predict all of the target variables. This is the standard independent variable data that the model will be trained on. Think of it as the raw data, or all the information you have before making any predictions. This is the first regressor in the chain. It uses the initial input features, x, to predict the first target variable, y1. The output of this regressor becomes an additional input for the subsequent regressors. The second regressor in the chain. It uses both the initial input features, x, and the prediction from regressor 1, y1, to predict the second target variable, y2. It leverages the information from the previous prediction to improve its own accuracy. The final regressor in the chain. It uses the initial input features, x, the prediction from regressor 1, y1, and the prediction from regressor 2, y2, to predict the third target variable, y3. This is where the chain's sequential nature is most apparent. These are the final predictions made by the regressor chain for each of the three target variables. These are the model's output that will ideally correlate to the actual target values, y1, y2, y3. This indicates the order in which the target variables are chained in the regressor chain model, based on their correlation strength. y1 is the most significant predictor and its outcome impacts the subsequent variable. The arrow signifies the flow of information, from y1 influencing y2, and y2 subsequently impacting y3. This order is crucial, as it reflects the dependencies between the target variables.